So now let's go ahead and look at interpreting regression, just sort of a summary video. So in this case, we're going to essentially write a paragraph interpreting all the information we have. So in this example, a study was run on the relationship between the inches of rain the previous night and my commute time to work in minutes. A linear correlation was found with a regression line y equals 34 plus 31x and correlation coefficient r equals 0.51. So let's just do some quick comments. Our x variable here is going to be the inches of rain the previous night. Our y variable will be the commute time to work in minutes. Technically, this is actually the predicted commute time. We do have our linear relationship. Oops. The correlation coefficient of r equals 0.51. This is a moderate, almost weak correlation. It's positive. So we can interpret the correlation coefficient. We can interpret the y-intercept if it makes sense. We can interpret the slope. We can make predictions. These are all things that we can talk about. So let's just run through them all and then we'll build a sentence or a paragraph after the fact. So the first thing we have is we can interpret our correlation coefficient. We can do first its statistics vocab. So this tells us there is a moderate, positive, linear relationship between the inches of rain the previous night and my commute time to work. Next up, we can do our general public version. So general public, we have a positive relationship. That means high variables of one are paired with high variables of the other. So the more or nights with more rainfall, or nights with more rain, tend to have a longer commute to work the following day. So that's just based off the correlation coefficient. We have two sentences that we can write. Next up, we can take a look at our y-intercept. So our y-intercept, if we scroll back up, the 34 is our y-intercept. 31 is our slope, positive 31. So we have a y-intercept, which is 34. We want to know, does it make sense to interpret? So the first thing we have to ask is, does x equals 0 make sense? We actually did this example in the video on interpreting the y-intercept. So does x equal 0 make sense? 0 inches of rain in a night absolutely makes sense. Next up, we want to know, would we have data near that? So is there data near x equals 0? We have plenty of nights with 0 inches of rain, so I would expect so. We have lots of nights with no rain. And then does the y-intercept make sense? So does y equal 34 make sense? So our commute time of 34 minutes makes sense. So we have our 3 yeses. We can interpret the y-intercept. And we have then that if there is no rain the previous night, we would predict my commute to take 34 minutes. Next up, we look at slope. So in this case, our slope was 31, a positive 31. This is 31 over 1. So our change in y is the change in commute time. Our change in x is the change in rain. So our generic sentence, we are looking at for each additional inch of rain the previous night, my predicted commute time goes up by 31 minutes. Next up, we can make predictions. We can pick any x value we want. It's rare that we get an inch of rain all in one go. Let's go ahead and pick half an inch of rain. So let's pick x equals 0.5, a half inch of rain. Then we would predict that y is equal to, we have 34 plus 31x. Take that 0.5 and plop it in our x. So y is 34 plus 31 times 0.5. Or y is 34 plus 15.5. Or y is 49.5 minutes. So if there was a half inch of rain the previous night, my predicted commute time is 49.5 minutes. And then I realized I never commented on the accuracy. So for our accuracy, our correlation coefficient was R equals 0.51, I believe, if I remember correctly. Yes. So a correlation coefficient of 0.51, this is on the low end of the moderate. So this linear model is only somewhat accurate predictor. So the regression line is only a somewhat accurate predictor. So if we wanted to put this all into a paragraph, we have all of our sentences. We could just rewrite everything I have written as a sentence. So we have there's a moderate positive linear relationship. Nights with more rain tend to have a longer commute. So let's put this all together. So all together. We have, there is a moderate positive linear relationship between the amount of rain the previous night, so the inches of rain the previous night, and my commute time to work. Nights with more rain tend to have a longer commute the following day. If there is no rain the previous night, or was no rain the previous night, my predicted commute time is 34 minutes. For each additional inch of rain the previous night, my predicted commute time goes up by 31 minutes. If there was a half inch of rain, the predicted commute time is 49.5 minutes. And finally, these predictions are only expected to be somewhat accurate. So that is running through most of or all of the various interpretations we've seen, condensing them into a paragraph. Your project 2, you will be doing something very similar to this.